record on this computer. Okay, we are going to go ahead and get this hooked up. And I'm just going to talk a bit about the forthcoming exam, which is not this week. Okay, so what's on your plate for this week? Okay. And just, I try to be very open about my pedagogical reasoning with my students, meaning that I try to be open about the way I do things, the way I do them. So once you finish once you finished your Josephus problem, which has a faraway due date because I know how people are still working on that. I will work on getting the maze assignment due date up this week, as well as the due date for the recursion, which is the next big one. So we have 3 big labs, essentially 3 big exercises this semester that I do. The first is the solitaire encryption / Josephus problem. The second is our recursion problem. And the third is our hangman / Wordle, because what you have to do for this also works for making a Wordle that people cannot win. So those are the 3 big ones. Now, so and those are the ones therefore that are worth a lot of points. Now with this one's worth 200 points. And it's got a due date of September 27th. I will zoom in so you can see that. Exam 1 has that will be done in lab on the 30th. So Friday the 30th. Just to make sure that you have ample time to be prepared. And even though I will have planned on moving on and having due dates for the maze solving already up and stuff like that, the maze solving covers stacks and queues, which are really just simplified linked lists. So I focus on array lists and linked lists on the exams. There's nothing about stacks and queues on the exam. Okay. So it's up through so the first exam is up through module 4. Your second exam, which will be sometime around week 11, will cover up through trees, and hash sets. Okay. So there is quite a bit of distance for that. Now, with regards to the exam, I want to do it electronically. I am not sure if that's feasible, depending on the format that I want to do it in, which is the part group format, the 2-stage format. And it may be that we do the group portion on paper, but the individual portion is done electronically. There's a couple reasons I like doing these electronically, especially for this class. Whereas on 1051, I don't like doing things electronically. Doing things electronically limits the kind of questions I can ask you, because if I wanted you to do it electronically, then there's an assumption about the questions I'm going to ask and the resources that you're going to have access to. Specifically, that you are going to have access to your IDE. Now, on this, which, believe it or not, is more of a disadvantage than an advantage. Now, this has nothing to do with the quality of the questions that I ask or the types of questions I ask, and everything to do with the fact that if you're coding in an IDE, you are on an exam or any point, you are going to get an error, an exception that's going to appear because you missed some weird syntax thing, right? And then you can spend like some absurd amount of time trying to fix that error to make sure that you can test your code. Whereas if it's done on paper, you can just write down your code. Oh, you missed the semicolon, right, somewhere in there, or open parentheses somewhere in there. You don't notice. I might not notice. And if I do notice, I'm going to dock like maybe somewhere between 1/10 of a point and a point, depending on the severity of the issue that you've just had, right? Mainly I dock minor amounts of points for syntax errors to call attention to that. Not necessarily to say, your code's all wrong. But the point being there is that when you have your IDE, it's very tempting to kind of waste time doing that. So just be aware of that. Also, having an IDE means I can't ask you questions along the lines of what happens when this code runs. Here's some code, tell me what it does. Instead, I ask more kind of conceptual questions like, here's some code, draw what happens to the linked list. Make sense? As well as questions about other things. I will send this out as an announcement, but I believe it's available in files currently. If you go down to the files, you should be able to access exam 1 practice right over here. This is a practice exam I wrote a couple years back. But it still covers the same exact material. So it's not precisely out of date or anything. But it was written back when I did paper exams. And it's got more questions than I would deem appropriate on an exam. Typically what I do is I write more questions than I need. And then the questions I don't use, I shove into a practice exam and hand it to the students, which means that you get a fair approximation of the questions I'll be asking. So I will send this out an announcement on Thursday, but if you want to see it beforehand, you can check it out in the files tab. But here, right, I can say, hey, please indicate which node is being referenced by the chain of variables. Write a sequence of commands that'll do something, draw what happens. Now, this was again done with the assumption that you do this in on paper, but you'll be doing a lot of this, on a computer most likely. Suppose you have some list of integers, right? These are questions that you would expect to find like on the second lab. So some questions you'd expect to find on the second lab, and then some questions that deal with just making you think and do things with linked lists. I'm especially fond of the merge method on problem 15 and this method, which asks you to reverse a linked list. That's actually a classic interview question. Although, right, interview questions typically they're meant to take up 45 minutes. This is typically the first step to a interview question. And here I've been talking without my mask, I suddenly realized. Geez. All right. So reverse is a doubly linked list. This method will be an instance method, right? And typically what happens is that they'll ask you, okay, you've done this now with the doubly linked list. Now can you do it with a singly linked list? Okay, you've done it with a singly linked list. Can you do it without using any auxiliary or ancillary data structures? Can you do it with that? Can you do it in place, in other words? So it kind of builds up in difficulty for that one. It's a classic interview. Nobody uses it anymore because it's such a well-known interview question. Now, for a lot of questions, by the way, well, what about so if we see module 2 and module 4 represented, what about module 3, which was big O notation? Well, I'm lazy with that regard. A lot of questions will simply have this. What is the time complexity of the algorithm you just wrote? Which will probably be O of n or O of n squared, depending on how you do it. The other way I use that is that I have restrictions in other problems saying you must run in O of n time. On the exam, what I have instead is a restriction that says, hey, 5 points, your solution runs in O of n time or something like that. So if the problem's worth a bunch of points, or 20% of the points will be worth does this run in O of n time? Now, my exam will be, I'm going to obviously be shortening my actual exam that I typically give to account for the fact that you have a smaller time limit, which is 1 hour, 20 minutes. But otherwise, again, unless I can figure out how to do it all electronically, my plan is you take your first pass electronically on Canvas, and then you get asked identical questions, if not or near identical questions in the group setting. as far as what resources you can use, definitely not open internet, but I have a fairly robust kind of guide I have a fairly robust like sequence of things that you're allowed to use. The exams are open book, open note for this class, where a note is defined that anything, so open book, meaning any copy of the textbook that you have, be it electronic or physical. And a note is being defined as any physical piece of paper or any electronic note that sits currently on your computer or on your personal cloud or on Canvas. In other words, you can download it, you can use it. If it's available to you without having to use a Google search, you can use it essentially. But you can't like go and ask for answers on Stack Overflow, because then that negates like almost 90% of the easy questions that I can ask you. And most of the hard ones too, you know. So I try to put some reasonable restrictions on what the note policy is, which is that acknowledging that programmers use documentation. So feel free to download that Java documentation if you need to, or any kind of notes that you need. If it's available on your personal like OneDrive or iCloud or Google Drive, that's perfectly valid. Okay. Also, I plan on going over the practice exam the day before the exam. So just to make sure that you are prepped for that. Because I find that students find that useful to know what those answers are. So I don't necessarily provide an answer key. That being said, I'm going to give you a bit of freebie here. The freebie I give every semester, and I will give it every semester until I see that students don't get it wrong, because even though I tell you it's on the exam, I still get a subset of students who get it wrong. Okay, on the practice exam is this question, 20 points. A list can be implemented in a number of ways. Compare and contrast an array list and linked list. In which situations would you use one to implement the list over another? I asked that question, and I've started telling students I asked this question on the exam, although I break it down in a bit further categories, asking how I want you to compare and contrast them. But I want you to know, but I'm specifically care about basically how do array lists and linked lists differ? What kind of operations do they differ in? How do they both, and they both also use up space in a different way. So that's the kind of first thing to focus on, space. How do they both waste space in a different way? Because they both waste space and they both inefficiently waste space, but they do so in different contexts where one might be better than the other. The second kind of category is how do they perform for the edit operations, your add remove operations? Where would you prefer to use one over the other? And then the third category is, of course, the access operations, your get and set. How do they differ in those kind of categories? Now, I tell you these things, and this is an exam that is open note, and your notes can be electronic. So what should you do for this question? Yes, but we can do one better. Copy and paste your answer that you pre-wrote before the exam. Because you know what the question is going to be now. So you want to definitely definitely work on this question before the exam so you can have this ready to go. And in fact, I will go over a correct answer on Thursday. And yet students still miss out on like 4 points or so because they'll miss a couple clauses and cases. There are because I want you to be fairly detailed in this one. Okay. So there are, but I go over this, and typically the students who miss this are the students who don't watch my lecture videos and don't show up. So, and I find this one an appropriate one to talk about or use. Now, with the way that I might weight it a bit differently because of the the way exam is going to be structured. It might be a 15-point question as opposed to 20, but it's going to be on the exam and worth a good chunk of points, enough to make the difference between a letter grade. So because I consider it important to know. So a good chunk of points on the, so that's one chunk of points. The other chunk of points will be dealing with like some array, linked list that has some special restrictions on it. Because those are pretty easy to, because it builds on what you already know. But definitely you want to practice on using your linked list exercises. And if you had trouble with lab 2, going over that. All right. Any questions with regards to that? Yes. The very last one. The very last one on the practice exam, and I'll be sending this out on Thursday. But if you want to get a preview of it, you can duck into the files on Canvas. Specifically on the side, there should be a files tab over here. And it is the last one, the analysis question. All right. Anything else? All right, so my plan for the day is to help you all with your issues or any issues that you might have in your labs. Because I know some of you have kind of hit like a point like, oh, okay, I've been working on this a while. I'd rather kind of hold off because the due date is a bit further away so that I could get some help from Professor Rosen or until I can work on this and have dedicated time to work on this class. All right. Sorry, I'm going to stop recording.